So there are so many materials available on the market today, choosing the right one can be quite confusing, but it's really important obviously to choose the best material for your component and for the environment that it's going to be going into. We've worked with thousands of clients over the last 40 years and are putting together this video to give you some advice on things to pay attention to when you're choosing the material for your component. The first thing that we want to say is to be open to new and alternative materials. There has been a massive explosion of new materials through blending and highly specific customization that actually it might be worth now going back to reconsider what material you specify. So we would advise being open to new materials and to really just providing a very clear brief as to what it is you need the material to do and allowing us to work with a wide selection of material providers and compounders to come up with the perfect material for your application. The second thing is to consider the environment that your component is going to be used in, so the in-service environment. So there are a number of different considerations here. So firstly, we might have regulations and legislation that you have to comply to. So that's really important to know, obviously, when selecting the right material. The second thing in a similar kind of vein is with regards to material leaching. So in some environments or in some applications, it's really important that materials don't leach. And so, for example, in food, medicines, and actually also underground. Flame retardancy, that can be important again. So does your material and your component need to be flame retardant or not? Which brings us on to temperature, which is one of the biggest considerations, really, because some materials can go right up to really high temperatures and down to low ones, and others can't. We also need to know about electrical conductivity. Do you need your material to conduct or to insulate? Is that important or is it not? So moving on from that, there are then a number of different other considerations. So is there any chemical or oil exposure? Is there any humidity exposure or other moisture? What about fuel or ozone exposure? And then with regards to ongoing long-term weathering, things like UV and just general exposure. How much of that is important, and making sure that you get that brief totally correct up front and have considered all of those different elements to make sure that the right material is selected. The third thing to consider is the mechanical performance required from your component. So what about the stiffness, the strength, the flexibility of the material? How important are each of those elements? What's also really important here is to look at failure mode effects analysis, and so looking at the whole product performance. So what is important to the whole product? So the fourth thing is not to over-specify. So it's really important to allow tolerance, but unfortunately people can sometimes feel they need to allow too much tolerance, and by allowing too much tolerance you can often completely discount a large number of materials that would have been perfectly suitable for your application. So whilst it's important to allow enough tolerance and to be sure what that tolerance is, one of our pieces of advice would be to not over-specify. If you only need a sure hardness of a certain level, then don't over-specify, because it can actually open up a whole range of different materials that might not be available with a higher specification. The fifth piece of advice for selecting the right material for your component is to conduct thorough testing. So how a material performs over time changes based on mechanical stresses and also then the environment. To test one without the other is only really looking at half the story. So it's really important, obviously, to test the product under stress, but also to test it in the actual in-service environment in which it's going to be, and to ensure that your component lasts for as long as it needs to. In fact, if it's really a vital component and if time allows, it actually would make a lot of sense to look at a number of different materials concurrently and test them over time and in the environment to see which performs the best. So to summarise, the 5 things that we would say pay attention to when selecting the right material for your component are: firstly, make sure that you're open to new materials. There are so many new materials available nowadays. Secondly is the environment, so making sure that you know the environment that your component is going to be used in. And thirdly, you know the mechanical stresses and the performance that is expected from your component. The final 2 things are: firstly, don't over-specify. So don't over-specify what you need from the material, because actually allow a bit of tolerance but not too much. And finally, ensure you conduct proper testing of both the product itself and the product within its environment, as otherwise you're only looking at half the story.